Welcome to your 8.2 video notes on surface areas of prisms. By the end of this, you're going to be able to find the surface area of a prism. Let's get started with the notes. First off, surface area, what is it? Well, it's the sum of the areas of all the solids' faces. Okay, we learned about faces in the last section, so remember it's just the flat side of a three-dimensional object. So this has 6 faces. Now the surface area is if I find the area of each of those faces and add them together. That's surface area. Now another thing you need to be aware of, especially the textbook emphasizes this strategy more than anything else. I don't, but it's just an option that you have. It's called a net. It's a two-dimensional representation of a solid. So if I were to take this, we call this a rectangular prism, okay, and I were to unfold it and then flatten it, it would look like this, all unfolded. So imagine cutting open a cereal box and then unfolding it. This is what it would look like. All right. Now the book recommends that we redraw this as this shape and then find the area of each one and add them together. I feel like that's one too many steps and it can really get messed up as you're unfolding it, especially if you put the width and the length in the wrong areas or the height or whatever. So I have a different strategy that's different from the book. But if you like the book strategy, feel free. You can make the net and then find the area of each one. If that strategy works for you, if it makes sense, by all means, go for it. All right. So let's find the surface area of this rectangular prism. So the first thing I like to do is identify the number of faces. Okay, so we see this is a rectangular prism. So like I said, picture a cereal box. Well, there's the front side, the back side, the top side, the bottom side, the left side, and the right side. So there's 6 sides altogether. Now we have to find the area of each of these sides and then add them. So the best way to help you with this is to stay organized. So what I do is I literally label each side. The front, so this side right here, that I'm tracing, that is the front. Okay, so when I find the area of that, well, it's a rectangle, so it's going to be length times width, 7 times 3. I get 21 inches squared. Okay, that's the front. Now that's one of the sides. There's also the back. Okay, that side right there. I'm trying to trace it out so you can see it better. That's the back side. So the back. Now here's the deal. They only label as much as they need to. So it's very important that you keep track. If this is 7 inches long, that means any side that goes in this direction is also going to be 7 inches, at least in regards to prisms, okay? So that means the back side is 7 inches by 3 inches as well. So 7 times 3, which is 21 inches squared. All right, now I'm going to clear this off. All right, next we have let's do the top side. So this right here. I'm going to trace it out. This is the top of the figure. Okay. It is also a rectangle, so I'm going to call that the top. All right. And let's see. It has a length of 7 as well, so it would be 7 times. But now the width is different. The width of this was going up and down. This one's kind of going from front to back. That's the 4-inch side. So I need to make sure that I understand that the width is 4 inches. 7 times 4 is 28 inches squared. All right, so that's the top. Now I'm going to do the same thing but for the bottom. Okay, this one's a little easier to see, so bottom, we're going to label that. All right, this one's also 7, and if you look, it's also 4 because from the front to the back it's 4, from side to side it's 7. So 7 times 4, which is 28 inches squared. All right, so we have 4 of the sides, 2 more to go. All right. Next, I have the left side here, so I'm going to trace this out again. Okay, left side, so I'm going to call that the left. And I see that it is also a rectangle. Now, again, this is a two-dimensional drawing of a three-dimensional object, so the shapes are going to be a little weird, okay? But if you were to look at this from the front side, you know, in section 8.1, when we drew the sides of the figures, this is still a rectangle, though, so keep that in mind, okay? So this is the length, which is 4 inches. Oops, 4 inches. And the width, up and down, or you could even say the height, is 3 inches. So 4 times 3, which is 12 inches squared. And then we're going to do the same thing all over again, but with the right side. So right here, same deal. So that's the right. It is also 4 inches by 3 inches, so 4 times 3, which is 12. Okay. Now, usually it won't take you this long to go over the problem. I just wanted to make sure you understood all the parts that I'm seeing. So the front, back, top, bottom, left, right, and where am I getting these numbers from? Okay, just from the lengths that they tell me on the shape. Next, since we're finding surface area, we're going to take all of these numbers and add them together. And if you want to do that in a calculator, perfectly acceptable to me. That's what I'm honestly doing right now. So 21 plus 21 plus 28 plus 28 plus 12 plus 12 gives me, I'll scroll down to give myself a little more space here, 122, and don't forget your label, super important, inches squared. And that's your final answer, and this will be your work shown. Pause the video, copy this down. Just a reminder, if you prefer to redraw your figure as a net, so like this right here, and then label each side width, length, height, all that stuff, that's by all means, that's the way the book teaches it. I prefer this strategy because it keeps it more organized, much easier to see, a lot less information gets lost. So, it's up to you. All right. So that was rectangular prisms. There's also triangular prisms. Now, the name kind of gives it away. It's a triangle as its base and triangle as its other base, and it's connected by straight sides. If you take a look, triangle has the front and the back, and it's connected by 3 rectangles, typically. Okay, could be a square too. Pause the video, copy this down. Okay, you don't have to do this middle one too. If you just did this and this. This is called the net again, by the way, just as a heads up. All right. So, we're going to do the same thing all over again, but I'm going to move a little bit faster this time, so if you need to pause the video, rewind it, feel free. All right. So, same steps. I'm going to trace the figure out so I understand where all the parts are. So I'm going to start with the front. That's just where I prefer to start. Okay, this is the front side. And I notice this time it is a triangle. The area of a triangle is found a little bit different. We take half times the base, which in this case is 12, times the height, which is straight from the top down to the base. In this case, it is 5. Make sure you look all around to find exactly what you need, okay? Because I need this length right here. So this 8 doesn't matter. This 13 over here doesn't matter. I need the length from top to bottom. Well, the only one that matches that is the 5 over here. Half of 12 is 6. 6 times 5 is 30 centimeters squared. Now we're going to do the back side, and the reason I'm doing the back next is because it's the exact same as the front. Okay, it is also a triangle. It also has a base of 12 and a height of 5. So half times 12 times 5, and that equals 30 centimeters squared. Okay, so that's it for the bases, the triangles. The triangles are done. Okay, when you have a triangular prism, you're only going to have 2 triangles that you find. The rest of them are going to be rectangles. All right, so let's go with this side right here. I'm going to call this the right side just because it's on the right side of the figure. I notice that it's a rectangle, so I'm going to take the length times the width. Well, the length is 8, width is 5. 8 times 5 is 40 centimeters squared. All right. Next, I'm going to call this, I guess, you could call it the left side, you could call it the top. Honestly, this actually proves a point here. You can call it whatever you want. Whatever information, whatever way you need to say it to stay organized, you do it. So if you want to call it the left, feel free to call it the left. I'm going to call it the top side because it just looks more like the top to me. But regardless of what I call it, it is a rectangle. It's got a length of 13, a little bit longer this time, and a width of, well, this is a little more confusing because it doesn't go straight across like this. It's got that diagonal, and it's going from front to back. Oh, this one's going from front to back. So 13 times 8. I'm going to have to do a little bit of calculation here. That's 104, so 104 centimeters squared. All right, that's the top side. Now, lastly, I need to do this side right here, the only other side that I haven't found the area of. And this is why I list them all out like this, because what's the only one I haven't done? I haven't done the bottom. Okay, this is to help me stay organized. So the bottom, well, it's very clearly a rectangle. I mean, I'm not the best tracer, but you can see that it's a rectangle. It has a length of 12 and a width of 8. See, it goes across 12. It goes front to back 8. So I'm going to take 12 times 8, which I believe is, 96. So 96 centimeters squared. All right. Then just like before, we add them all up. So on my calculator, I'm going to take 30 plus 30 plus 40 plus 104 plus 96. And that gets me a nice even 300. It also doesn't hurt to double check your answers every once in a while as well. All right. So pause the video, copy this down. This would be the work that you need to show. If you have all the examples and you have all the notes done, then what I want you to do is go to IXL and practice RMG. Good luck.